Right. I'll be starting in a minute. I was waiting for more participants to come on, but I think I'll start with the people available. So I hope you're still active. You can drop a message on the chat box to indicate so that I'll know I'm not speaking alone. Good evening, everyone. Good evening, Ola, Pat, and Divine. Today we'll be talking about machine learning and integration with agile development procedures. Last week, there was a little introduction about what machine learning was and what agile development is all about. If you have any questions about that, I did not receive any questions last week, but if you do have questions, please drop them here. Although I'll go, we continue. So, good evening, Alan. I see your message. So, agile development. Let me start by giving a small analogy. Imagine you want to build a house, right? And the architects have designed the framework that your house will follow, what it will look like from the ground up. And then you pass on that design to, say, the engineers. You wouldn't wait until the engineers tell you they finished the house before you go checking how far they've gone with building the house. You would go almost every week to inspection, where you go regularly to see what work has been going on in your new house. If you spot any mistakes or any of the supervisors spot any mistakes, you can easily tell the engineers to fix it and before moving on. Now imagine that you had waited for the house to be complete before you go inspecting, and that mistake was overlooked. Then you would have to break down the house to fix that mistake and rebuild it. So that's where agile development idea, the philosophy came in. Software developers and project managers were frustrated with having to deal with massive errors after building software. Under the traditional method, which it has been imagine a waterfall just falls down from top to bottom. It's only when it gets to the bottom that it collects into a pool and then maybe flows somewhere else. That was the prevailing method of building software. So people just built, everyone played their part, and on the final day, where any errors would then be corrected. That was so tedious, and that's where agile development philosophy comes in. It's just an idea of managing this process, making sure that mistakes are caught easily, that the customer understands what the developers are doing, and that the customer gives feedback immediately, and any mistakes are fixed, and the product is delivered quickly and on time with no bugs. We are specifically talking about software development here. So that's the simplest explanation of the agile development process. So it came up, as I said, it came up as a way to make sure that you push working software in a short time, and you collaborate with the customer, the owner of the software, and then you fix mistakes easily and quickly. You spot them easily and quickly, and you fix them. Now, how can we integrate AI or machine learning into this procedure?
I was wondering.
Let's not forget, AI and machine learning need data to operate. They need data to make decisions. That data. So first, we should look at where we could get data from the agile development process. At which stage in this philosophy using agile can we generate enough data for an AI or machine learning model to follow? Before I continue, please indicate that you can still hear me. Don't want to be speaking alone. And if you have any questions, please drop me so I could go over them immediately. Okay, all right. Ola has indicated that I'm audible. All right, so I'll continue. I was talking about where we could get data from. Now, development cycles are divided into sprints, are divided into short periods of time where everyone focuses on a single task, delivers that task within that time frame. That in itself is a source of data. For example, which team could not meet the deadline? Which teams delivered easily? Which teams had complaints about the time sprint duration? Which teams before time? Collecting this data helps you understand. Right. Let's go back to the house analogy. Say the people in charge of fixing the ceiling have 1 week to complete, but then they run into a problem somewhere, maybe at a cornered wall, a rounded wall, and within that 1 week, and they are not done. The data you get from that is rounded walls are a source of problem for engineers in this team, right? That's the kind of data you also get from sprints. So that's one way you get data. Another way is during stand-ups, when you have to report back what you did the previous day in the next meeting. So these stand-ups, you can tell them all your successes, your challenges they had, what is preventing you from completing your task within the sprint duration, and your progress initially. Now, all this information can be collected, and even a human being looking at them. Please mute your mic. All right, thank you. I was talking about the source of data. You're just joining us. I was talking about the source of data for machine learning models when agile development processes are considered. Now, I was talking about the daily stand-ups and this kind of data you get from there. You get feedback from developers, information on which tasks they couldn't complete. You get information on what tasks are challenges or what they had to overcome to finish their tasks. Now, this information is in form of text, right? The machine learning models can understand text now. An example would be ChatGPT. They're using natural language processing. So they could easily read the sentiment off of this text you're sharing. Now, I was trying to compare what a machine can do with what a human being can do. Imagine that you collect this data from the sprints and then from the daily stand-up. Even a human being can say, oh, this team in particular has issues when it comes to implementing so and so feature, right? This team in particular is very fast, quick in delivery, this and that. Those are information that a human being can use to make their own decisions. So it is the same thing here. You're collecting that data for the AI to use. Are you following? Please just indicate that you're following so I can move on to. I will ask about 2 or 3 questions from this section. So please, if you're paying attention, you should write some things down. So can you still hear me? Okay. All right. So I've talked about the daily standards as a source of data. I hope you understand that. I've also talked about the sprints and where they have short periods of time to build a feature and then come back with either completion or failure reports. Another way is backlogs. Now, here we're talking about a list of constantly changing requirements for the app. For example, you develop the software, you put it out in the market, and then you start receiving complaints. Oh, this button, when I click it, I have to click it twice to work. When I click the first time, it changed color to this. You will now update your backlogs of tasks to do with, oh, fix this button color, or fix this double clicking button. So that backlog keeps changing. When the team reports a challenge, you add it to the backlog. It's like a list of items to go over. You can also collect that information and use it to make decisions. Say, okay, this section, for example, you on a certain page on your website, users cannot submit a form, and you all receive that report daily. You would now set that as a high priority task. You say, submitting this form is high priority. Users are complaining, so we need to deal with it immediately. Those are the kind of information that you collect and store in your backlogs. It's a living list. It's constantly changing. That could also be a source of information for AI to use. So those are the three main sections that you can derive data or AI models. But what can the AI models do with this data? Let's start with the last example I just gave. Now you know you have a backlog, you have a list of items to go over and then fix or work on with your team. If you use that data to train the AI models and machine learning models, over time, it will begin to predict. It can know which of those backlog items are usually high priority. For example, if your team always reports a particular page, a particular feature as needing urgent attention, you can train the machine learning model to recognize that, oh, anytime I see this task, this means it is high priority, and it can automatically prioritize that on your backlogs so that it will be the next thing you work on. A real life example of this in action is Spotify. Spotify was also given as an example in the last lecture. It's a good example of a company that has integrated this system well into their workflow. What Spotify does is to monitor their apps and all their software. Then, depending on the features that users use the most, they will now update their backlogs, their list of to-do items to match those features. Especially if there's complaints, if there's the notice that, oh, some services are not working when needed. So, for example, on Spotify now we have music videos. Say users try to watch videos every time and the videos don't play, or when you try to switch back to audio, because you can switch video and audio, and that feature breaks down. Spotify is monitoring this, right? And over time, they will learn, the system learns to prioritize those kind of problems that are reported. They will now elevate the priority to half of the failure on their systems. So that's a very good example of using machine learning to monitor your backlogs and change it automatically, depending on the kind of reports you are getting, based on how urgent it is, the impact it will have on your project, and a whole host of other positive reasons. All this is to help you build and deliver software on time and correctly without problems. Another area that you can employ this AI after collecting the uh, data is predictive analytics. This simply means using you recognize in that data to make forecasts on potential errors or potential successes before they even happen. Just indicate if I'm still audible, so I know I'm not speaking alone on the call. So in this way, using machine learning models in this way helps you to catch the problems before they happen. Going back to that house example I gave, where the engineers had trouble navigating round walls, or the people doing the ceiling had trouble navigating round walls. If you've collected information in the past that round walls and ceilings don't work well together, you can immediately, when the engineers are approaching that task, you can team, hey, there's a potential problem here, right? And then they can pay close attention to it. That's one way. It's just like a weather forecast that we watch on TV. That's the same thing they do. They collect weather information and weather conditions of a place over time, and then they can use that to predict, oh, it's going to rain today, or it might not rain enough, or there will be lightning, and so on. So that's another way you can employ machine learning models in predicting challenges before they happen. This is very helpful in software development because we have code reviews, right? This is a real life example that I also engage in every day. We have code reviews when you push a feature. What we now use, before AI, it used to be manual. The project manager had to go into the code, look at it, and then approve it or not. But now we have AI that you can tell what to look for. And so when you make a push, the AI automatically goes through the code and looks for those things, those patterns that it was trained on. If it doesn't find it, it automatically fails that code and doesn't approve it. But if it passes, it also automatically approves it. One example of this software that we use is called Agent Farm. You install it on any of your code storage services, and when you update, it goes through the code and checks for these things. If you are familiar with GitHub, option to use Copilot, their AI model as a reviewer. When you add Copilot as a reviewer and then you make an update, Copilot goes through your code, finds potential problems and reports it, and writes comments for you to review your code. So these examples I'm giving are actually in use right now as we speak. Your product is delivered timely without bugs, right? Because if the AI does not approve your feature, it will not get integrated. Why this is very useful is because even though project managers can do this by themselves, the AI is faster. It can go through that code in seconds. It can go through more than 2 teams' projects simultaneously and deliver reports timely, faster, and it's more reliable. You can be sure that the AI will not make mistakes that a human would otherwise overlook. So that's the second way we can employ these machine learning models when we have collected the data necessary for it. Another way is now making decisions for your teams. I was talking about daily stand-ups in, I think, in part one of this lecture. If I also mentioned that machine learning models can use natural language processing to understand the sentiment behind a human being's message. You can employ machine learning models after collecting these stand-ups, the messages, the reports. You can ask the machine learning model to go through this and identify positive reports, negative reports, or just any form of reports as a whole. So you can go through what the team said and then tells you, oh, the sentiment here is negative. Pay attention to this. The sentiment here is positive. Of team A has positive reviews today, or team B has negative reviews today. So you know which team to prioritize your decision process, whether you are to downsize the team or hire new developers or reduce their tax or reduce their sprint period. Oh, sorry. Since my network is breaking. Can you hear me now? Am I audible now? You can also indicate at which point you lost me so I can go back and review. Please, if you lost me at any point in time, you can indicate here and I will go back and talk about it, please. Sorry about that. Okay, there is no message about what get lost. Anyway, I'll go on now. So you can also use this to make, as I was saying, make plans for each team. Yes. So you can decide that team A cannot handle complex tasks, and so you can now reassign tasks for them and on time to make sure that the project or the product is built. So I think I've covered the three main areas that machine learning can be applied on the data you collect from the team during startups, on the data you collect at the end of the sprint, and on the data you collect from the backlogs. Those are the three main ways we can apply AI. But why would we need to do this? Why do we need to integrate machine learning with all this with ease? Well, uh, one of the major reasons why computers are now being used to replace human beings in many sectors, so many industries, is speed. That are way faster and have higher accuracy than human. So number one, you need and more accuracy from your data. From the data you've collected, you need more accuracy for your teams to make proper decisions. Then you automate this process. If you need faster feedbacks, you will use a machine learning model to automatically go through your system reports, your team reports, and then make decisions timely and in real time. The computers are way faster at this. We also need to collect evidence to make decisions in future. Machine learning models now we know can generate text and reports in any form. Currently, you can use ChatGPT to make documents, PowerPoints, text, write emails. So instead of waiting for your team reports, your machine learning model can go through the code, go through your backlogs and generate reports for you automatically on a day-to-day basis. So, summary, what you need the AI to do is to be fast, and smarter than a human being. That's why you use it. And that's where AI is useful and better than a human being. So if you have any questions regarding what I've said so far, please drop it on the chat. Like I said, I will ask questions on my own. One question would be, what did I say about predictive analytics? What is predictive analytics? And how is it used here? How is it used in agile development process? Please write that down. You can send the answers in the chat, or it should be requested later. I spoke about predictive analytics when I was talking about the ways of applying machine learning models. In case you were making notes. So I gave example of Spotify using already in real life. I also mentioned that I've used it myself in my own work. I mentioned Copilot. Okay, well, that's correct. It is the use of past data to predict behaviors and probable outcomes. That's a very apt way to put it. Thank you. Shows you were paying attention. So I'll mention other examples now. We've all heard about companies like Microsoft developing AI, X is developing AI, Facebook is developing AI. Internally, they all use these tools to generate reports and generate code and review their own code before they deploy the features instead of relying on their human teams. We also heard last year that many of these companies were downsizing, which means they were cutting costs and hiring more developers than necessary. Must released some information about why they did this. It's available as a slides I can share later. And also can share to the students. So the reason they gave is to deploy fast, fix fast, and roll out changes fast. So they tend to roll out more, roll out often. According to them, they need to roll out changes to as many changes as possible, as fast as possible. We released that slides in 2017. Their AI is called Watson X. So what IBM did is collect data from code repositories, test suites, that's applications that run automated tests, and bug trackers. So those applications that track bugs in the code. They selected all this data from multiple sources, use it to train their AI, such that the AI was able to detect patterns that could lead to bugs, even without seeing the bug first. Yes, it could indicate areas that developers were more likely to have problems, and then report it automatically. We also detect where integration would fail. I hope you're still hearing me. And then those areas were reported, and then IBM will fix them. What IBM later reported was that they had a 15% reduction in critical bugs. Those are bugs that would lead to their software or their system crashing in production. So that's a very good example of an application of machine learning in agile technologies. So what they did essentially can be summarized as what Tesla is doing in their cars today. The car, the AI on the car. Oh, so sorry about that. I think my network is fluctuating. I was talking about IBM's AI and how they implemented it, how they trained it with code, how they trained it with bugs from other people's codes, and how they trained it from testing data from multiple sources, and then using that their trained AI to predict their own critical bugs, uh, areas that could lead to problems, and then they had a 15% reduction in critical bugs in production. So sorry about the modding sound. Is it clearer now? Oh, okay. So sorry about that. I hope you didn't miss anything about AI's IBM's AI. What did I say the name was? If you were listening. Oh yeah, that's correct. It's IBM. What's next? Yes. All right. All right. Another example would be Microsoft Azure. So this one is for people that do DevOps. Unfortunately, I'm not an experienced DevOps developer myself. I'm a software engineer, and then I hand over to the DevOps team. But I've had the opportunity to witness the impact of using AI on DevOps. Some DevOps platforms automatically provision servers in, in case of any downtime or heavy traffic, heavy bandwidth. The system can automatically provision new servers to ensure that your service stays on and does not crash. And Microsoft uses AI models to monitor patterns that lead to these crashes, and they can react on time when they notice these things, like even before the crashes happened. So they could be detected and handled immediately. So the impact of this is that your service stays on for longer, there is reduced downtime, and it's easy to deploy. So that's it. I already spoke about Spotify, now Microsoft, and IBM. Those are three good examples. Please take note of them in case you see them in your quiz later. So, what lessons could we learn from all these things, everything I've said so far, especially from the examples? Mhm. Ola, Ali, and who else? What lessons could we learn from this? You can drop it in the chat. That the use of AI now. Oh, sure, sure. It's to improve performance, but performance of who? Is it the software or the developers? All right, I'll explain that. The AI used in software development now is used to improve the capacity of the developers. I call it performance too, but essentially it's to aid the developers in their work. So their work is easier and faster, and then they can push new features on time and readily and correctly to the customers without having to go through all those challenges of the past that I described. Another, you may be seeing information or posts online about AI replacing humans. That may be possible in some areas, but when it comes to agile development and machine learning models or AI is not replacing human beings anytime soon. It is just assisting. The AI is used as an assistant here in detecting problems faster making decisions faster. Those are things that human beings do, but with the aid of AI, it is done easily and faster than before. Okay, that's one lesson. Thank you, Ola. One other lesson that is very critical is that we need data. You need data to train these models. You need data to make decisions, just as a human being would. So without collecting enough data from your team, from your company, it would be impossible to create any machine learning models that could aid you in your own team and your own work. But we have open source models now. We even have models you could pay for that have already been trained from other people's examples in the past that you can use in your own company, your own team, in your own agile development process. So one critical lesson is you need data and clean data, because if you feed the AI wrong data, it will also reproduce wrong data. I think back to the example I gave in the last class when comparing ChatGPT 1 versus the current version of ChatGPT. Back then, you could tell that ChatGPT was subpar. Okay, IBM is a software development company. You've never heard of IBM? Or are you asking about the IBM's AI? Please clarify. Ali?
I'm asking about the IVM AI. I don't understand. When you were
Okay,
explaining about the IBM, so I don't stop it was cracking. Didn't get it.
okay, I get your question now. Sorry about that. Okay. So I mentioned IBM when I was talking about a real world example of an AI model or a machine learning model that has been integrated into agile development. It's called IBM Watson AI. What it does is to go through the code that the developers write, the messages, the commit messages that they give, the test results, and what they report at the end of their sprint period. Remember, I said the sprint period is the period of time where developers just are assigned a feature to build, and every day they report back what they did the previous day. The end of the sprint period is the end of that particular feature. It's like a deadline. So the AI takes all that information that was collected over time from different sources and has been trained on that. So it could now predict when a problem will come up in the bug. It could predict, for example, in the code, oh, this section usually has half problems from past data that I've seen. It could immediately report the problem before it happens, right? Say, for example, okay, using that house example I was giving that time, somebody that is more experienced in constructing the building comes around and sees the engineer attempting different methods on the ceiling or on the wall. He can quickly tell this, yeah, this thing you are doing doesn't work, and this is why. That's exactly the same thing the AI is doing, but it's faster. It could do that in a split second. It could see you writing code and know that, oh, you're about to make a mistake. That's what I'm saying. That's what the AI did. It's for, actually. So it is it's like an assistant that helps you to detect areas that could lead to bugs, areas that will fail. And IBM had reported that it did just that. They had a reduction in their bugs. I hope I've answered your question. Ali Jaziri. Right? It works just like the diagnostic in cars now. They can tell you, oh, you have a flat tire, or your car pressure is low. You should look at it. That's how the AI works. If that is a better example, I hope I've answered the question correctly. Okay, I was talking about the lessons we learned. Mentioned that we need data. I also mentioned that AI is not replacing humans. You need it alongside human beings to make those decisions. It's just that the AI is faster and can go through huge amounts of data faster than a human being would. And the most important lesson is that integrating AI into your procedures, whether it is agile, whether it is practically anything now, helps to improve your capacity and your performance. And that's about it for this lecture. I have written down notes. I will share the PDF later, and you'll see these examples I've given. But before then, I should ask another question before we go. Uh, Given, hello, can you still hear me? From everything I've said about Agile, I mentioned that there are daily stand-ups. I mentioned that there is a sprint periods. I mentioned that there is a backlog that you keep track of. I also mentioned that the developers are working in collaboration with the customer. Customer feedback is very important. You cannot build without the customer knowing. Like I said, you can't just give your house to engineers to build without inspecting. So my question is, in all those sectors I've mentioned, in the stand-up, in the backlogs, in the building of the software, where else do you think machine learning can help? Where else do you think it can be applied apart from everything I've mentioned? So what do you think? So the first question I asked was, what is predictive programming? Predictive analytics, sorry. Also have predictive programming. And now the question is not clear. Okay, let me rephrase. I explained what agile development is, right? I explained from the beginning that it's a system of organizing developers to build products, right? Where you don't allow them to work blindly. You don't just plan and tell them, okay, go and work. You make the plan and then break down the plan into smaller pieces. Focus on those smaller pieces one by one. You have this period where a team focuses on a small piece. We call it sprints. And after the sprint, you're expected to have finished that feature. But if you don't finish, you will have another sprint to fix it. So I explained all that about Agile. I also explained that the customer is in collaboration with you throughout that process, right? If you understand all that, the question is, where can machine learning help? Where can you apply machine learning to that procedure? Anywhere in that process, where can you apply machine learning? I hope it is clear now. No feedback. If you still don't understand, try to remember what I said when we started. What does Agile help us do? Fix bugs on time, deliver working software on time, ensure that the customer is happy with the product. So think about those, those features, and then think where you can use machine learning to help you. I think with that, we have come to the end of this lecture. I'll hand over to the hosts to continue from there. All right. All right. You're welcome, Ola. Welcome back, Emilio. Please take over. We have ended our class. Oh, a little information here, please. Those questions I asked, please write them down. You will submit it as an assignment. I will also send my own notes, like as I initially promised. Please don't forget. You will submit it as an assignment. Those two questions about predictive analytics and how it helps, and any
Hi,
other
hi
ways we can
everybody.
apply machine learning. Thank you.
Hi Ola, hi Ali. Thanks for taking the session.
Hi,
I
good
hope you
evening.
guys really learned. I hope you really learned a lot. Hi Ola, can you mute yourself and speak, please?
Hi, good evening.
Hello, can you hear me? Inudu, please, can you hear
Hi,
me?
good evening. Good evening, I can hear you.
Oh, yes, I can hear you.
Okay, okay, I didn't hear what you said, please.
We can hear
Let me
you. I
check
think
this.
the network is bad on your end.
Okay, yeah, because your voice is quite low. Okay, so thank you very much for taking the session on. Okay, yes, thank you for taking the session on the machine learning as concerns to agile decision making, right? And I'm sure the assignment questions have been given to you. Please do well to like turn it in. I know we're talking about AI here, and you would want to also use AI in your assignments. If you are finding difficulty in the assignment, please reach out to Inyodu at I am Inyodu on X, or you can drop your questions on the community chat, and then we would respond appropriately. So this class will hold next week again, and we'll be having another interesting topic still on AI. So please tell your friends that are not here to join, and you can do well to make friends with people on this call in case you need uh clarity on something. And thank you so much for joining. Thank you, Inudu, for honoring our invitation. Thank you for accepting. speak to the students. We are so grateful. Thank you so much. Thank you everybody for joining. And we hope to see you next week, same time, same medium. Bye, Ola. Okay, yeah, wait, before we go, let's have feedback. Hi, Ali. Hi, Ola. How was the session for you? What did you learn exactly from the session?
I don't know if you can hear me. I've been talking.
Yeah, I can hear you.
Oh, okay. My feedback. Okay, so I realized that AI can also be used by software developers to better improve their work, and then the use of agile methodology, like we can break down instead of doing the work or the project at a stretch, we break it down into sprints, and then each sprint we do feedbacks and all to make sure that the work is done as it's supposed to.
Okay. Okay. So that's cool. What do you do? Like, what's the nature of your job? Like, what do you do normally? Are you a student or? Okay, I think I've seen the NYSC badge and all.
Yeah, I'm currently serving. I I use mostly I work with data sometimes, but not much data. So I use data analysis and all of that. But I want to see if I can venture into software development. Maybe.
Okay, okay, okay. I'm sure we'll get to. Sorry, I'm quite straining my ears to hear you, Sha. So, but I know you said you are serving, you work with data, and you also want to learn something about AI. Is that correct?
Yes, that is correct.
Okay, I hope we get
Yes,
to
that's correct.
connect, like, and with the other people on the call in subsequent classes. I hope the network, and I'm sure the network should be better by then. So please, wherever you learned in the session, do well to tweet, tag us, Valicop official, Valicop Global, yeah, and tag I am in Yodu on X. Let's just tweet what you learned in the session. You can make a screenshot of these, post it, let people know that you are learning something interesting, and like that's social proof of what you are learning, right? So we'll see you next week. Thank you for joining and good night. Bye.
Thank you. Bye.